everyone. Welcome to iPint. This video is a quick reference for our course on human factors in aviation. Use this video as a reference for the course, and if it resonates with you, you can enroll for the human factors in aviation course by clicking on the link mentioned in the description box. You can also contact us via the email and phone number mentioned on the screen for customized discounts and to know more about the corporate training programs. I hope you like this program and to see you on our course. Enjoy your preview.
Welcome to the first part of our training program, Introduction of Human Factors. This section lays the groundwork for everything that follows. Before we can tackle the complexities of human error in aviation, we need to build a solid foundation, a shared understanding of what human factors actually mean, where it comes from, and why it matters so deeply in our industry. In this part of the training, we will be covering 5 key topics together. We begin with the introduction itself, establishing what human factors is as a discipline, how it evolved within the aviation industry, and why understanding it is no longer optional for anyone working in this field. From there, we move into influencing human factors, exploring the specific conditions, pressures, and personal states that shape the way people behave and perform at work. Because human factors do not exist in isolation, it is influenced by everything around us and within us. Next, we look at various studies and outcomes, drawing on real research and real incidents from across the aviation world. These studies give us evidence-based insight into exactly how and why human error occurs and what the consequences look like when it goes unchecked. We then turn to common mistakes in aviation, the errors that appear time and again across the industry, regardless of airline, country, or aircraft type. Recognizing these patterns is one of the most practical things you can take away from this training. And we close this section with the error iceberg, one of the most powerful concepts in aviation safety. As we have already touched on, what we see on the surface is only a fraction of what is really happening. This topic will help you understand the full picture and why looking deeper is always worth the effort. 5 topics, each one connected, each one is essential. Let's begin with the introduction and build from there. Now, let us begin with the introduction of human factors in aviation. Most of you might have a question, what is this about? Or many of you also have prior knowledge about it. But today is the time to focus again. Let me show you some statistical values. Studies show that out of all accidents or incidents happens within the aviation industry, only 20% of those are caused due to technical issues, else 80% caused by humans. Did you get surprised? Let us begin our topic with human performance. Did you know 8 out of 10 aviation incidents and accidents happen because of human error, not mechanical failure? This means that people are often the weakest link in aviation safety. That's why understanding human performance, how we think, act, and make decisions, is critical to keeping aviation safe. Did you know that 80% of aviation incidents are caused by human factors, not the aircraft itself? That means the people behind the operation are the biggest variable in aviation safety. But who are we talking about? There are 3 key groups in aviation: where human factors play a critical role. First, the aircraft flight crew. This includes the pilot and cabin attendant. Human factors here involve errors that occur during flight moments where a lapse in judgment, fatigue, or miscommunication can have serious consequences. Second, the maintenance crew. This covers aircraft engineers and aircraft technicians. Their human factors involve errors made during maintenance. A missed step or oversight on the ground can directly impact safety in the air. Third, the ground support crew. This includes the pushback team and other ground teams. Human factors here relate to errors during ground support operations, from aircraft handling to turnaround activities. Across all three groups, the message is the same. Human error is preventable. Understanding where and how errors happen is the first step to stopping them. So, what exactly are influencing human factors? The European Aviation Safety Agency, EASA, defines human factors as the study of human capabilities and limitations in the workplace that covers human psychology, physiology, workplace design, and the environment. In other words, anything and everything that shapes how a person performs their job. But let's put that in even simpler terms. Human factors equals anything that affects human performance. Think about it across three pillars. First, psychology, how we make decisions, how we handle stress, how our minds behave when we're overloaded. Second, physiology, fatigue, our body clocks, physical health, and the body's hard limits. And third, environment, the tools we use, the lighting, the noise levels, and the culture of the organization around us. When all three align poorly, when a tired person uses outdated equipment in a badly lit workshop under pressure from their supervisor, that is when accidents happen. Understanding human factors is our first line of defense. Take a look at this graph, and what it reveals might genuinely surprise you. When academic researchers studied aviation accident data spanning from 1950 right through to today, they uncovered a remarkable shift. Back in 1950, technical failures accounted for approximately 80% of all aviation errors, things like mechanical faults, equipment failures, and engineering limitations. Human error, by comparison, made up just 20%. But here's what's fascinating. As technology advanced, as aircraft became more reliable, systems became more sophisticated, and engineering standards improved. That picture completely reversed. Today, technical error has dropped to just 20%. Meanwhile, human error has risen to account for 80% of aviation incidents and accidents. What this graph tells us is profound. Technology has largely solved its own problems. The challenge now, the frontier we must focus on, is the human being in the system. This finding is documented in the published research titled Modeling Air Accident Investigation Methodologies from the Technical Factor to the Human Factor. Let's go deep inside and understand the mechanical versus human causes for accidents. We need to know why safer aircraft are producing more human-caused accidents, not fewer. Here is something that might surprise you. Over the past 40 years, airline safety has improved significantly thanks to better aircraft, better air traffic control, and better weather forecasting. These are real, measurable achievements. But here is the paradox. As aircraft have become more reliable, human error has become more prominent, not less. Why? Because as technology improves, complexity increases. More systems mean more interfaces, more checklists, and more opportunities for something to be missed or misunderstood. And there is something else worth sitting with. It is far easier to fix a faulty component than to fix a faulty person. A part can be replaced. A habit, an assumption, or a cultural blind spot. Those take real, intentional effort to change. That is precisely why human error in aviation has received so much focus in recent years. It is now the primary frontier of safety improvement worldwide. Let's talk about complexity. Complexity creates new risk. Modern aircraft are engineering marvels, but their very complexity introduces new opportunities for human error. More systems mean more interfaces, more checklists, and more chances for something to be missed. Next, we talk about error. Human error is now the focus. Because of the enormous progress in mechanical reliability, human error has received increasing attention in recent years. It is now the primary frontier in aviation safety improvement worldwide. A faulty part can be replaced. A faulty habit, assumption, or culture takes real effort to change. That effort starts here, in training like this one. Now, we're going to look at the 3 most common accident types in the aviation industry, and more importantly, understand why they happen and what we can do to prevent them. Let's start with number 1. Tail strike during landing or takeoff. A tail strike occurs when the rear of the aircraft makes contact with the runway. This typically happens when the pilot raises the nose too steeply or too quickly. Before the aircraft has built up enough speed to safely lift off. It's a split-second decision that can cause significant structural damage, and it is, in most cases, entirely preventable. Moving on to ground handling damage. This is any physical harm caused to an aircraft while it's stationary on the ground, during parking, pushback, towing, loading, refueling, catering, or maintenance. The aircraft isn't even flying, yet damage still occurs. The primary culprits, ground support equipment, and almost always human error. And finally, landing gear issues and runway excursions. These occur when the landing gear fails, malfunctions, or is not correctly configured during takeoff, landing, or ground operations. The consequences can be serious. The aircraft may veer off the runway, the gear may collapse, or in the worst case, the aircraft lands with the gear not deployed at all. Now here's the common thread across all 3 of these accidents. That is people. In each case, human performance, a lapse in judgment, a missed aircraft maintenance check, a moment of inattention is at the root of the incident or accident in the aviation industry. That is precisely why we are here today, because understanding these risks is the first and most powerful step toward eliminating them. Now, we are going to look at the case study of Aloha Airlines Flight 243, which happened on the 28th of April, 1988. On the 28th of April, 1988, a Boeing 737 operated by Aloha Airlines took off from Hilo heading to Honolulu, Hawaii. It was a routine inter-island hop. And then, shortly after takeoff, the upper section of the fuselage was ripped away. One flight attendant was lost. 65 passengers and crew were injured. It is almost miraculous that the aircraft landed at all. The aircraft had been inspected the night before. So how did this happen? The NTSB investigation found that the aircraft was 19 years old and had completed 89,090 pressurization cycles, well beyond its 75,000 cycle design limit. D-check had been carried out in piecemeal early morning sessions rather than as a complete, uninterrupted inspection check. An epoxy adhesive had failed, allowing moisture to corrode fuselage rivets. And, perhaps most disturbingly, a passenger noticed a crack in the fuselage before boarding. They said nothing. The human factor failings were numerous. Fatigue from inspections conducted between 1 and 3 in the morning, complacency from repetitive, familiar work, pressure to release the aircraft on schedule, outdated service bulletins from Boeing, and a lack of training and adequate facilities to detect the deterioration. Every one of those failings was preventable. Every one of these reasons is present in your workplace as well, in varying degrees. This is why we train on human factor. Let's take a closer look at human factor involvement in Aloha Flight 243. What makes this incident so significant for our training is not the mechanical failure itself. It's everything that led up to it. Every single contributing factor points directly back to human performance. Let's walk through them one by one. First, working at the wrong hour. The inspections were being carried out between 1 and 3 in the morning. Think about that for a moment. Our bodies are simply not designed to perform critical, detail-oriented work in the middle of the night. Fatigue doesn't just make you tired, it quietly degrades your judgment, your attention, and your ability to catch mistakes. Second, pressure to get the job done fast. The aircraft had an early departure scheduled, and when there's pressure to meet a deadline, corners get cut. Not always intentionally, but they do get cut. In aviation, that pressure to hurry up is one of the most dangerous forces we face. Third, outdated paperwork. The service bulletins from Boeing were no longer current. Here's the hard truth. You can follow a procedure perfectly and still cause harm if you're following the wrong procedure. Keeping documentation up to date is not a bureaucratic exercise, it is a safety-critical responsibility. Fourth, we've done this 100 times. This one is particularly dangerous because it doesn't feel like a problem. When a task becomes routine, complacency quietly takes over. Critical steps get skipped, warning signs get overlooked. Familiarity without vigilance becomes a liability. Fifth, not trained for the specific aircraft type. General aviation knowledge is valuable, but it is not enough. Each aircraft has its own systems, its own characteristics, its own quirks. If your team hasn't been trained specifically on the aircraft they're working on, gaps in understanding are not just possible, they are almost certain. And sixth, the right tools simply weren't there. The facilities needed to correctly carry out the fuselage, bonding and corrosion work were not available. Even the most skilled, experienced engineer cannot do their job safely without the proper equipment. This is a management and resourcing failure, and it has real consequences. So what does Aloha 243 teach us? It teaches us that accidents are rarely caused by one single failure. They are the result of multiple human factors combining: fatigue, pressure, complacency, poor training, and inadequate resources, each one chipping away at the safety margin until there is none left. That is why we study human factors, not to assign blame, but to understand and to do better. Let me take you back to the 10th of June, 1990. Case study, BAC 111, Flight 5390. A British Airways BAC 111 departs Birmingham, bound for Malaga, Spain. It's a routine flight. Passengers are settled. The crew is at the controls. Everything appears completely normal, and then, without warning, the forward windscreen fails. The aircraft's captain is violently sucked out of the cockpit. Cabin staff grabbed him immediately and held on with everything they had. For 22 minutes, while the aircraft is still in the air, the captain's torso remains outside the plane, exposed to freezing temperatures and extreme wind forces at altitude. The co-pilot takes control and successfully brings the aircraft down to a safe landing at Southampton Airport. The captain survived, but not without serious consequences. He suffered frostbite, bruising, shock, and fractures to his right arm, left thumb, and right wrist. Now, let's talk about what went wrong. The night before the flight, the windscreen had been replaced, and that's where everything started to go wrong. The wrong bolts were used. The replacement bolts were slightly too small in diameter and too short in length. It sounds minor. It was anything but. The manager did the job himself, rather than assigning it to a qualified technician. That decision alone removed a layer of expertise from a safety-critical task. No proper inspection of the new bolts. They were checked by eye only. No measuring tools, no glasses in poor lighting conditions. That is not an inspection. That is a guess dressed up as one. And then, he also signed off his own work. The same person who carried out the task also approved it as complete. No independent review, no second pair of eyes, no duplicate check whatsoever. And finally, the procedure didn't require pressure or duplicate checks. It never required pressure testing or a secondary verification. The system that was supposed to catch human error didn't, because nobody had designed it to. So what does Flight 5390 teach us? It tells us that a near-fatal accident can be traced back to a single maintenance task carried out the night before by one person in the dark with the wrong bolts and no one checking behind them. Not a mechanical failure, a human one, from start to finish. This is why independent checks matter. This is why proper tools, proper lighting, and proper procedures matter. And this is why no one should ever sign off on their own safety-critical work. This is why human factor is significant. Now that we understand what happened on Flight 5390, let's dig a little deeper. because the real value of any case study is not just understanding the event itself, but understanding the human factors behind it and what we can actually do differently going forward. We have broken it down into 5 key areas. Let's go through each one. Number 1, lack of awareness. The wrong bolts were selected because nobody stopped to check the specifications. This wasn't sabotage. This wasn't recklessness. It was simply a gap in knowledge. And that gap had catastrophic consequences. The preventive measure here is straightforward. Provide proper training to the workforce. People cannot be expected to get it right if they haven't been taught what right looks like. Number 2, complacency. The bolts were checked by eye, not measured with instruments. This is a classic example of someone thinking, "I've done this enough times. I know what I'm looking at." But confidence without verification is dangerous. The fix? Implement a proper procedure and task sign-off process, one that requires actual measurement, not assumption. Number 3, environment. The work was carried out in poor lighting and the technician wasn't wearing corrective glasses. Ask yourself, how can anyone be expected to identify a 0.66 mm difference in bolt diameter in the dark without the right eyewear? The environment set this person up to fail. The solution is regular safety audits to make sure the working environment meets the standard required for the task being performed. Number 4, circadian effects. Long hours and irregular shift patterns impaired the judgment of the people involved. Our bodies have a natural rhythm, and when we disrupt that rhythm repeatedly, our ability to think clearly, spot errors, and make sound decisions deteriorates. The answer here is to standardize shift patterns and build in proper rest periods. This isn't about comfort. It's about cognitive performance and safety. And number 5, organizational failure. There was no requirement for pressure checks. There was no independent duplicate inspection. The system itself had no safety net built in. And when a system has no safety net, one human mistake is all it takes. The preventive measure, periodic assessment of critical tasks and eligibility, regularly reviewing who is authorized to carry out safety-critical work, and ensuring the procedures around those tasks are robust enough to catch errors before they become accidents. So let's bring this together. 5 human factors, 5 preventive measures. Every single one of them is actionable. Every single one of them is within our control. Flight 5390 did not have to happen, and with the right awareness, the right procedures, and the right organizational culture, incidents like this don't have to happen again. That is the entire purpose of human factors training. Not to look back with regret, but to look forward with the knowledge to do better. Let's now look at some of the most common mistakes in the aircraft maintenance industry that are directly linked to human factors. And I want you to pay close attention here, because none of these are rare, one-off events. These are the kinds of errors that happen regularly across the industry at every level. Let's go through them one by one. Installation. Working from memory instead of the manual. A technician carried out an installation without referring to the aircraft maintenance manual, the AMM. Instead, they relied on what they remembered. Now, experience is valuable, but memory is fallible. Procedures exist for a reason, and the moment we decide we know better than the manual, we open the door to error. Activation, odotetse, forgetting to switch equipment back on. After completing maintenance work, the technician forgot to reactivate the equipment. The job looked finished. The paperwork may have even been signed off on, but a critical step was missed. This is a textbook example of task fixation, so focused on completing the work that the final step of returning the system to service was simply overlooked. Missing tools. Leaving tools inside the aircraft. Tools were not returned after the job was done and were left inside the aircraft. This is not a minor housekeeping issue. A foreign object inside an aircraft can interfere with critical systems, jam moving parts, or cause catastrophic damage in flight. Every tool that goes onto an aircraft must be accounted for before that aircraft moves. Engine oil. Wrong fluid in the wrong place. Hydraulic oil was put into the aircraft engines instead of engine oil. Two different fluids. Two very different consequences. This type of error usually comes down to rushing, poor labeling, inadequate lighting, or simply not double-checking the result. Potential engine failure in the air. Cabin seat. An unlocked seat that injured a passenger. A cabin seat was left unlocked after maintenance work was completed. A passenger was subsequently injured. This one hits close to home because the victim wasn't even part of the maintenance process. They were simply passengers, trusting that the aircraft they boarded had been properly prepared. That trust was broken by one missed step. And wingtips. Two aircraft that should never have touched. During pushback, the wingtips of two aircraft collided. Both aircraft were grounded as a result. This comes down to situational awareness, communication, and coordination on the ramp. All human factors. In a busy airport environment, the margins are tight and the consequences of inattention are immediate. So what do all 6 of these have in common? Not a single one involved a mechanical fault. Not one was caused by the aircraft itself. Every single mistake on this slide was made by a person. Under pressure, in a rush, working from memory, or simply not following the procedure that was right there in front of them. And that is the most important message of this entire training. We are capable of preventing every one of these errors, not by being perfect, but by being disciplined, by following procedures, by checking our work, by creating a culture where it is always acceptable to slow down, ask a question, and verify before signing off. Because in aviation, the cost of a mistake is simply too high. Now it's time to have some human factor-based quiz. On the screen, you need to read the question and answer from the given options on right-hand side. So the question is, do humans make mistakes? First option is yes, they make mistakes. The second option is no, they don't make mistakes. The third option is, sorry, I can't say. The fourth option is, I don't want to comment. What are your thoughts about it? Comment down below in the comment box. We have one more question for you. On the screen, you need to read the question and answer from the given options on right-hand side. So the question is, are you interested in mitigating human factors-based errors? First option is yes, I want to mitigate. Second option is no, I don't think so. The third option is sorry, I follow instructions. The fourth option is I don't want to comment. What are your thoughts about it? Comment down below in the comment box. Now it is time to discuss why human factors matter in aviation. Let me start with a question, and it's one that investigators have asked after almost every major aviation accident in history. How could a combination of such simple mistakes have caused such a disaster? That question alone tells us everything we need to know about why we are here today. Aviation is one of the safest forms of travel in the world. We have incredibly advanced aircraft, highly trained crews, and robust safety systems. And yet, accidents still happen. And when they do, they shake our confidence and remind us that safety can never be taken for granted. Here is what the data consistently shows us. No accident has a single cause. When investigators conduct a thorough review of any aviation incident, they almost always uncover not one mistake, but a series of human errors that occurred before the event. In fact, in around 10% of all aviation accidents, maintenance errors are found to be part of that chain of events. And that brings us to the most important concept in this entire training, the chain of events. Think of an accident not as a single moment, but as a sequence, a series of small errors, missed checks, and poor decisions that connect together until something goes wrong. The good news? A chain can be broken. If we identify and address human factors at any point in that sequence, especially at the maintenance level, we can stop the accident before it ever happens. Now, before we go further, I want to say something directly to you. How much you take away from this training depends entirely on how open you are to it. If something doesn't sit right with you, say so. If you disagree with a point, raise it. That conversation is not a disruption. It is exactly where the most valuable learning happens. We recommend you participate in training from time to time, not because you'll forget it, but because the more experience you gain, the more it will mean to you. Let's move to the next. Now it is time to discuss the error iceberg. What lies beneath the surface? I want you to picture an iceberg for a moment. You're standing on a ship and you can see the tip, sharp, visible, impossible to miss. But what you cannot see is the enormous mass sitting silently below the water's surface. And that is exactly what makes it dangerous. Aviation accidents work the same way. When a major incident occurs, it rarely comes out of nowhere. What we see, the accident itself, is just the tip. Beneath it lies a long chain of smaller events, missed signals, and low-level mistakes that nobody noticed or nobody reported. This is what we call the error iceberg. At the top, the visible tip, are the serious and fatal accidents that make headlines. These are the events that trigger full investigations by national authorities like the FAA, EASA, and the NTSB. The world sees these. They are documented, analyzed, and reported. But by the time we are here, it is already too late. In the middle section, just below the surface, are the incidents that happen during operations, in-flight shutdowns, delays, aircraft accidents, personal injuries. Some of these trigger investigations, but many go unnoticed by the wider industry, quietly buried in local reports or not reported at all. And at the bottom, deeply hidden, are the low-level incidents, the near misses, the shortcuts, the small errors that happen within the work area never make it into any report. No one outside that team ever knows they occurred. Here is the critical truth. Airlines already investigate serious maintenance mistakes caused by human error, but the problem is that many incidents remain hidden, sitting in the middle and bottom of this iceberg, unexamined, unaddressed, and just waiting to become the next link in a chain that leads to disaster. To break that chain, we cannot only focus on the tip. We must have the courage and the culture to look deeper, to surface the incidents that happen every day before they ever become accidents. Because remember, an accident is never just one event. It is always the result of many incidents, and every one of those incidents is an opportunity we had and missed to stop it. Now it is time to discuss how to adopt human factors. Let's start with the most fundamental question in this training. Why do human factors matter? The answer is simple but powerful. The most important human factor in aviation is our ability to learn from experience and from our mistakes. And there is one golden rule that underpins everything we will cover today. If it has gone wrong once, it will probably go wrong again. That is not pessimism. That is a call to action. The key is to learn before it goes wrong again. Over the years, mistakes in aircraft maintenance have caused real harm to safety, to operations, and to lives. The industry's response has always been the same: develop better procedures, close the gaps, and, where prevention isn't fully possible, minimize the impact. Learn from experience. The most important human factor in maintenance and flight operations is our capacity to learn from past errors. Experience, when properly captured, becomes our strongest safety tool. Develop better procedures. When mistakes cause harm to safety or operations, engineers and managers develop updated procedures to prevent recurrence. If prevention is impossible, the impact is minimized. Minimize the effects. Not every risk can be fully eliminated, but it can be managed. The goal is always to reduce the likelihood and severity of any maintenance error reaching the flight deck. So the key takeaway is that human error in aviation is not a new problem, it is a persistent one. And persistent problems demand persistent awareness. So, did you understand the significance of understanding human factors within the aviation industry?
Yes, we understood that understanding human factors empowers professionals to think clearly, act responsibly, and prevent errors before they occur.
With this, we come to the end of part 1 of Human Factors in Aviation. I hope you're liking the training and excited for next part. Thank you.